Hello and welcome to our presentation on the Smith Chart Senior Design Project. My name is Ryan McGill.
And I'm Alex Kaylor.
Yes, and so we're going to be talking to you about a little bit about what we've done as well as just an overview of the system. So essentially the problem that we have right now is that the Smith chart downstairs is unusable as it is huge and we do not have a straight edge or a compass that is that big. So our solution is to use two LiDARs to determine where a puck is on the board and use a software interface in order to use these pucks as buttons to place compasses or place a circle and a line on the board. So that isn't super straightforward on how we can do that. So we want a few things. We want it to be easy to use. So somebody who is unfamiliar with this technology should be able to go up and clearly understand how to place the pucks, click the buttons using our design. We also need to be able to actually use the pucks, so using the LiDAR as an interfacing between a Raspberry Pi or processor and then outputting that to the projector. And then as well as we need to be able to calibrate our system. So we got to be able to know, over time these things may change, or if you bump the projector, you still are going to want to be able to update where the puck is being recognized as. And then we also needed to, another thing is you got to determine how big a projector you need, how beefy it needs to be, and how accurate it can be pixel-wise.
So we identified a few things that we really need to do, and Ron kind of touched on the first one. We need to make sure that we have the calibration algorithm that's robust, easy to use, and the user can kind of redo it pretty quickly. We also need to be able to recognize pucks pretty accurately. The Smith chart actually gets very dense along that far left side or right side. So you need to be able to determine the difference between points. We also realized that you kind of do two things. You either draw straight lines or you draw circles. So we kind of identified, okay, these are the two functionalities that we need to have, and from there you can do almost any Smith chart.
Right, and so going on and defining our minimum viable product, we need a projector that can fit the board size from a table essentially. So we thought about putting the projector on the ground or on the ceiling, but wherever it is, we want to make sure that it actually can cover the whole space around the chart, as well as red enough pixels to be accurate enough to where you place the puck. Because as you said, you're using a Smith chart, you're going to have some very accurate lines so you can see where they cross. Also, we need to have explanations on how to use it. So it needs to be, once again, easy to use by somebody who's unfamiliar with how it works. So somebody should be able to go up without somebody operating it and know and figure out how to use it based on instructions that we can give. And finally, it needs to have, aside from the straight edge and the compass, it needs to have a clear and undo. So we don't have an eraser on the board, right? So we want to be able to have some sort of data structure such as a stack to update as you add things to it, and then you can pop off the actions as you undo to fix mistakes and correct yourself. As well as you don't want to have to restart the whole program in order to do a new problem, so you're going to want to clear it. So those are two functionalities that we said have to be implemented in order to have a successful system.
So I want to talk a little bit deeper on how we actually do the calibration algorithm. You see two blue points kind of at the top of that image. So those are the 2 points that are input by the user initially. They're kind of arbitrary in terms of where they are on the Smith chart. However, we wanted them to be easily identifiable by somebody who doesn't really know what it is. Like I can't tell them to go to 1 plus J2 because they wouldn't know what it is. But I can tell them to put a point right on the center and right on the 0 degree mark on the far side. So they can select those 2 points, and from there, we have basically a side angle side triangle because we know the distance from the LiDAR and we know the angle between the two lines. So from there, we can solve the triangle and find an angle phi that we can call out the calibration angle. Then when the user places a new point, such as that black one, we can actually determine that additional angle, add it up, and then find the total angle and distance from the actual center point. Unfortunately, there are several cases to consider. So for example, where the point is now, clearly you kind of add up those 2 angles and then rotate it around to start it from that far angle. But if that blue point were on the inside of this calibration triangle, you'd actually have to subtract the two angles. So, so this algorithm has to be able to take into account those things. So we've determined several, we've made a lot of progress in several different areas at once. So we're getting data from the LiDAR and processing it, with some sort of unit. We're converting using the calibration algorithm I mentioned, and we're making really good progress with the GUI. Unfortunately, those separate things together aren't all you need to make a functioning system.
Yeah, so as Alex said, there's two kind of paths that the project has, and one of them is hardware and one of them is software. And so in the beginning of fall, we kind of had those as separate things. We realized those needed to be really close together because as we've talked about, you're getting this data from the LiDAR. We're going to have to process the data. So we've already gotten past kind of the interface between the LiDAR and the software. And so the next step is gluing these pieces together. So we have this data coming in, we're filtering out erroneous data and stuff that we don't need. But now we need to say, okay, well, here's a pug and here's where we're saying it is. And then actually putting all that together. So we have this GUI set up with buttons, but now we need to implement, okay, well, here's the point coming in. Here's the update that we have, or here is the pug recognition. We recognize that the button has been pressed. And so that's kind of the future steps and the integration that needs to happen post spring break. And with that being said, we have made a lot of progress on both the LiDAR front and the software GUI front. And so really it's just an interaction between those two now. And so if we can accomplish that, then we'll have a pretty solid minimum viable product. And if we finish that early, then we have plans to actually make it, or possibly add in some calculation back end so we can actually give you some stuff out and say, oh, well, here's what we calculated. There are some Python libraries that are built for that. So pretty exciting, and we're hoping we can get to that, but it might be a bit more difficult, more to chew to put it in our minimum viable product. So that's why we have it as, oh, well, here's an extra thing we can add there. And also the idea behind this is to have this open software for students to augment and add more functionality to it in the future. So yeah, that's our project.
Awesome.